Hey, Mrs. Talk.
Hey, Mrs. DuBois.
How are you doing?
I'm excited about ionic bonding.
You are. How'd your kids do?
Fantastic, of course.
Of course.
Of course. But maybe someone was gone.
Yep. Maybe some needed some more review.
Yeah. So
Yep.
since it was so much fun, let's do it again.
Obviously, so much fun. So, ionic bonding.
So.
Ionic bonding, if you guys remember, is between a metal and a nonmetal, kind of like sodium and chlorine that makes sodium chloride.
NaCl. There we go.
Yep, here's our sodium. Plus.
Chlorine. Remember we talked about this too when we were talking about compounds, that we said sodium by itself, chlorine by itself, not so much fun to work with. However, put them together and what do we get?
Some yummy salt.
Yummy salt. Way to go.
Now, if you guys remember, metals and nonmetals on the periodic table, we drew in our little zigzag line over here that separated the metals from the nonmetals. And remember, the metals were all these that are colored in yellow. Yes, including, I guess I could include the ones down below too, the rare earth. But we're going to be focusing more on these in here. And then remember, the nonmetals are those on the right side of the periodic table.
And
so
you should have those colored a different color as well.
Absolutely, we did that in class. All right, ionic bonding.
This is when we're going to transfer electrons. So electrons are going to go from one atom over to the other one.
Absolutely, and then and you're gonna form ions. These things called charged particles.
Hence, ionic bonding.
Absolutely, ionic bonding, charged particles. Now, here's a picture from your book, and this is an ionic bond between sodium and chlorine, where you can see that sodium has one valence electron.
Because it's in group number 1, so it gets one valence electron, and it's showing you this nice little arrow. So you can see that electron is actually going to move.
Yes.
Move over to chlorine.
And that's where that transfer is coming in. So now we've got our one valence electron. It's being transferred over to chlorine, and that's going to be the bond that holds them together.
Right, because remember, chlorine only had 7, okay, and sodium had 1. So both of them are unstable by themselves.
That's right.
They need to get the full valence electron set, which is either magic number 8 here. So chlorine's going to gain 1 from sodium. That brings it to magic number 8, and sodium then gets to drop back to its previous level, which of course was already full. With
8. Now, opposites attract, right?
Look at us.
Remember that one atom, that atom that loses its electron, is now going to be a positive charge, which sounds really weird.
It seems like it's opposite. It seems like if we're losing, we're subtracting, but don't think of it that way. It's
right.
Negative now because, or excuse me, it's positive now because it has more protons
right.
than it does electrons.
Right, because it lost that negative charge. So now it has more protons, just like you said here. Now, when the other atom gains the electron, now it's going to have more negative charges, so it is now a negative ion.
And remember, that term ion just means that it has a charge. So it can either be a positive ion or a negative ion. Just it has an overall charge. It's no longer neutral.
Right, right. All right, so to practice this, we're going to do one with potassium and chlorine because potassium is our metal and chlorine is our nonmetal. And you remember, metals are always written first.
Always first.
Always first.
And if you forget, just go ahead and look on your periodic table. Or when you're looking at the compound, it's already written there for you first. So you kind of know which part of the periodic table to start looking for. If you're like, oh, okay, you know it's potassium, so you know you're going to start looking on that left-hand side of your periodic table.
Right. So now we need to draw in the valence electron. So we need to do our electron dot diagram. And if you remember, potassium is in group 1, so there is only one valence electron. Chlorine is in group 7, and there are 7 valence electrons around chlorine.
So we're drawing them there as little pairs, and then one lonely little one over there.
Actually, I misspoke. Well, here, this should not be drawn in because we are going to make the transfer over. And actually, chlorine isn't in group 7. It's in group 17. It has 7 valence electrons. So now, once we have transferred that one over, potassium has a +1 charge because it lost that negative, and chlorine is going to have a -1 charge because it gained that electron. Now, remember, too, that these charges should equal 0.
Because that means now it's neutral again.
Right,
It's
right.
more stable now.
It's more stable, bonded together.
Okay, so there's your 3 steps. You draw your electron dot diagram.
Yep.
Draw your arrow showing that the electron moves, showing which way it
That's
moves.
right.
And then final step is now write the resulting charge of the resulting ion. So potassium now is a positive or +1 ion. Chlorine is now a -1 ion.
Absolutely.
This was fun. Let's do another.
Yay! Let's do barium and sulfur. Now, barium. I'm going to rewrite this so we can spread it out a little bit. Barium is in group 2.
Dose.
So there are 2 electrons. Sulfur is in group.
I wonder what it might be in. Let's try 16.
You're right, 16. And look, it's missing 2. It wants 2. Barium's a perfect match.
There we go. Match made in heaven.
That's right.
Or in science class.
Chemistry.
Chemistry.
Love. They're perfect chemistry. Have you ever read that book?
I have not.
Oh, good book. Good book. Okay, now we've made our transfer. So remember, our first step was to draw the electrons in. That's right. Electron dot diagram. Now we're showing our transfer. And then our third step is to put the charges on. So since barium lost 2 electrons, 2.
Lost 2 of them.
So now its charge is +2. Sulfur, the lucky guy, he gained 2. So his charge is -2 because now there's 2 more electrons.
But again, 2 positive charges, 2 negative charges. Overall, we've got a net charge of 0. It's neutral.
That's right. That's right. That was good. Should we try it? Should we make it a little harder?
Let's make a harder one. There we go.
Yay. Now,
BaBr2.
BaBr2, and you guys are going to soon learn how to name those things. That's called barium bromide.
Now there's 2 bromines, so she's going to put 1 on either side.
Yes.
Makes it a little easier to draw these.
Yep, because we want to show how they are bonded together. So in order to do that, we have to draw them on opposite sides there. All right, bromine. Bromine is in group...
I'm going to look at my periodic table, and it's 17. It's a halogen.
17, a
See me
halogen.
throwing in those terms.
Nice work, Mrs. Tolk. We've got our 7 valence electrons, because it's in group 17. And then barium. Barium is in group
Number 2.
number 2. Number 2. So now, this is kind of fun, because barium is actually going to share. It's with each bromine. So one barium is going to go here, and the other one is going to go right over there.
Right, because each bromine only needs 1 electron. So
That's right.
barium will give 1 electron to one of the bromines, and the other one goes to the other.
That's right. So now, barium, since it lost both of his or hers, I don't know, are they boys and girls?
Probably gender neutral.
Yeah, probably. +2. And bromine is going to now have a -1 charge here because it did gain 1. Only 1. And then this bromine is also going to have a -1 charge because it did gain 1. So now if we still add these up, it is going to be 0.
Right. And so it doesn't matter that bromine and barium separately are different because we have 2 negative charges overall, 2 positive charges
That's
overall.
right.
Still neutral.
That's right.
That's kind of like your final check to make sure that you did it right. Add up your
Absolutely.
positives and negatives.
Absolutely. Just make sure it equals 0. Now, I'm going to go through this one kind of quickly since we did the last one that's very similar. We have potassium oxide.
This one's just different. Now, in this case, we've got 2 metals and 1 nonmetal. The other one was 1 metal and 2 nonmetals.
That's right.
Same setup, though. You're still going to put the singleton in the middle. Though if there's 2, they're going to go to the outside.
Absolutely. Potassium. Looking at our period.
Number 1.
Group number 1. Number 1. We'll put 1 here. I'm going to put 1 right here.
Just
so
makes it easier.
it makes it easier to transfer. Oxygen.
Oxygen is over there. It's in group number 16.
Number 16. Now, I don't know. How do we want to arrange these? Should we put 2 down here?
Yeah.
Okay.
2 on top. That'd be 4.
That'd be 4.
We know it's going to share.
We do.
So we'll put 1 on each side.
We do. Okay. So now potassium has that 1. Look at oxygen likes this. It's going to gain those 2. So now it is full with 8. With that, it has all 8.
And that makes it stable.
It does. So now we've got 2 electrons that oxygen is gaining. So now it has a -2 charge because it has 2 extra negatives.
So 2 extra electrons.
That's right. And potassium lost its negatives, so it has a +1 charge. And this potassium did the same thing. +1 charge.
Looks good.
Looks
I've got
good.
2 positive charges, 2 negative charges. You're good to go.
We equals 0. Nice work. I think we're good.
I think we're good. Hopefully you're good now too. Practice them up.